Okay, here we are. We're at the end of the weak acid equilibrium chapter, and we have the big denouement question, the big question that says, if you can answer this one, then you got it all figured out. This is a question about the titration between a weak acid, benzoic acid, and a strong base, sodium hydroxide. And it's going to go through and it's going to ask you what the pH of the solution is after particular additions of a particular amount of the base. Now, what I'm going to do is I'm going to break this up into several different videos. The first video is going to offer a little bit of an explanation with the solution for part A. What I want you to do is think about what happens when you add sodium hydroxide to the solution of benzoic acid. You're going to make water and you're going to make the salt of sodium benzoate. Sodium benzoate has the conjugate base of benzoic acid in it. So as soon as you add some sodium hydroxide, you've created a buffer solution. And so what you need to be able to do, what makes these questions so challenging, is that you have to be able to sort out the chemistry, what's actually in the solution, how much solution there is at any given point, and how those things are interrelated in order to figure out what the pH is going to be. And so let's go ahead and let's get started with the first part. It's part A. It says, I just want to know what the pH of the solution is before we even get started with the titration. So 0.0 milliliters of addition means I haven't added any base. And so the only thing in the solution is the benzoic acid. And so the chemistry that's applicable is the Ka chemistry for the weak acid that is benzoic acid. And so we can just use an ice table in the normal way that we use an ice table. And so we end up with an expression that says 6.3 times 10 to the fifth, the Ka, equals the concentration of the products, and in this case, according to the ice table at equilibrium, they're x times x, or x squared, divided by the concentration of the reactants, which we've decided was 0.20 minus x. Now, let's see if our assumption works. Let's assume that x is small, so we can simplify this to 6.3 times 10 to the fifth, negative fifth, equals x squared over 0.2. What I get then is x squared equals 1.26 times 10 to the negative fifth. Taking the square root from both sides, I get x equals 0.00355. And so x seems like it is pretty small compared to 0.2. It's less than 3%, so we can say that our assumption is valid. And so if I take the negative log of that concentration, I get 2.45 as the pH. Okay, and so let's go. We're going to go on with the titration. I'm going to start adding some base. And once I start adding some base, I'm going to form a buffer solution. So that's going to change the way that I deal with the problem.